I'm Masako Yamada. I am the Senior Director of Applications here at IonQ. I joined IonQ about 3.5 years ago after 20 years at GE. And at GE, I worked with every single business unit at some point in time, as well as many of the US government agencies. So I do feel that I was able to absorb a lot of the use cases that are really endemic to enterprise and industrial AI. I wanted to talk today about some of the really important work that we're doing with a vital customer, vital partner, Quantum Basel. And we have recently entered the second phase of our collaboration with Quantum Basel, making the total value of our deal with them over $60 million. And what is our Quantum Basel collaboration? So currently, they have already installed and running a Forte enterprise system on their facility, on their campus. And we are now in the process of installing our new Tempo system. During this process, we have also worked together with them to develop applications. So today I'm going to talk about the applications we are developing with them using the Forte enterprise, and we can extend forward to when the Tempo system will come online. So this is a plot that kind of looks like a plot that Niccolo showed earlier. As a matter of fact, except for the y-axis, it's exactly the same plot. And what is it? On the x-axis, it's always the size of the problem. On the y-axis, you see things like cost to solution, time to solution, energy to solution, etc. It's very simple why the y-axis always looks the same. It's because if a calculation takes longer, we're basically saying it takes more energy and costs more. That's really what we're saying. And the kinds of problems we're trying to address are those problems where if you use a classical computer, the scaling is exponential, and if you use a quantum computer, the scaling is linear. That is the type of problem we are trying to solve, and in this particular case, we're trying to solve AI problems. So what are we trying to do here? This plot is something we've shown over and over again. What's different this time is we, with Quantum Basel, are actually measuring the actual energy that is consumed by their Forte enterprise system as they do these calculations. Likewise, we're doing the same exact calculation on GPUs, measuring the energy consumption, and actually trying to validate, is this curve true or not true? So the results of this work we plan on publishing by the end of this month on arXiv, so please hold it in suspense until then. But really what we're doing with Quantum Basel right now is using their actual systems to measure a lot of these curves that we take for granted. Next, the next thing that we're exploring with Quantum Basel is, so to speak, the potential for quantum computing to show small data advantage in AI. So when I was at GE, I spent about 3 years leading a team called Industrial AI. And industrial AI is very different from commercial or consumer AI. In consumer AI, you have billions of data sets, many images of cats, many images of dog, a lot of Amazon customers, billions of data points. That is not industrial AI. With industrial AI or enterprise AI, often the number of assets under management, 100, 1,000 trucks, 10 power plants. But then you have a lot of data about those 10 power plants, right? And one of the things that we talked about, which alludes to something that Martin said, is that the power of 1%. If a jet engine runs 1% more efficiently, that's a lot of money. If a power plant runs 1% more efficiently, a lot of money. If some kind of services agreement is 1% more efficient, it's a lot of money. So we try to milk these 1% of a relatively small number of assets, but then it's kind of hard because if you have a small number of assets and the number of defects or anomalies is pretty small, how do you construct a model? And that's, again, another one of the questions we're really trying to pose to quantum computing to ask. Is it possible that quantum computers are able to generalize these very small data sets within a sea of a lot of data, but not many assets? And this is another exploration that we're trying to do with Quantum Basel. So what are we trying to leverage here? What we're trying to leverage on the left-hand side is, let's say, small amounts of data. I only have 10 defects, 200 time series, right? Very small number of defects, and I want to construct an AI model. How do you do that? You do that by hitching a ride with a pre-trained foundational model, of which there are many. So you hitch a ride with some kind of large language model, pre-trained time series model, et cetera. And you basically say, okay, I will take my small amount of data, add it as a thin skin to an existing trained foundational model, and see if that fine-tuned model does what I'd like to do. And this is really the question that we're asking of quantum computing together with our colleagues at Quantum Basel right now. So what are we doing? This is the really exciting part. You can take a pre-trained foundational time series model from Amazon, from Google, it's already trained, and then you can literally retrain it or fine-tune it to look for energy anomalies, heart, signal anomalies, brain signal anomalies, automotive anomalies, using the same core foundation model, which, when you really think about it, is quite amazing. And what we're trying to do with Quantum Basel is to basically say, when we do the classification using this quantum fine-tuned model, do I see any advantage? Again, this is a work that we expect to be publishing in the next month or two, but I did want to hold you guys in suspense and just lay out the groundwork, lay the problem statement, and really set expectations for what we have coming soon. Finally, what I love about my job right now is that we interface directly with customers like you. So we run this idea by a lot of our customers saying, hey, if you could do a fine-tuning time series model, what would you do? And some of the use cases that our customers have mirrored back to us are right here. And maybe I can invite you guys in the audience to also think, if I had a pre-trained time series model, I have incremental amounts of proprietary time series data, what could I try to do? So this is just an ensemble of the voice of the customer that we've gotten, but we wanted to share it with you. So finally, the 3 points that I'd like to make here. Is it possible that quantum machine learning can really help generate insights when you have small amounts of data, hitching a ride on big data? Can we basically make this drop-in? What I said is that you can take a generic time series model and turn it into, right there, 3 different things, but it could be 7, it could be 17, 70, right? So it's drop-in. And finally, in terms of energy consumption, we've seen the scaling curves, exponential versus linear energy, time to solution, cost to solution. We want to actually measure that to see whether it's true. So thank you very much, and looking forward to your questions. Thank you.